Good afternoon, students. Today topic is Black 3, Unit 11. Black 3, Unit 11. That is synthetic strategies. So Black 3 is the synthetic strategies. And Unit 11 is introduction and target selection in terminologies. First, we are discussing one by one. What is the terminology used in synthetic strategies and what are the criteria for selection of target molecule? First we are discussing. First, we are discussing some terminology used in synthetic strategies. First, we are discussing terminology. So very important, this terminology. First is target molecule. Target molecule. So the definition for target molecule is the molecule which is chosen for the synthesis in the laboratories or the molecule which is chosen for disconnection in retrosynthetic analysis. So that is a target molecule. Simply we are taken, this is the target molecule. Carboxylic acid is the target molecule. So when this carboxylic acid is chosen in the disconnection in retrosynthetic analysis, so this is a retrosynthetic analysis. We are choosing this molecule in disconnection in the retrosynthetic analysis. Therefore, this is called as target molecule. When it is this carboxylic acid molecule undergo disconnection, undergo retrosynthetic analysis, first it is converted into cyano group. Carboxylic acid is converted to cyano group, and it is cyano group is converted into alkyl halides. And alkyl halides are converted into alcohols. Okay, this is a target molecule. The molecule which is chosen in the retrosynthetic analysis is called target molecule. So this is a retrosynthetic analysis. It is exactly reverse to the synthesis. So now the molecule which is chosen in the synthesis in laboratories is also called target molecule. So now we are synthesis this carboxylic acid from this alcohol is when this alcohol molecule reacting with SOCl2, then it is converted into alcohol converted to alkyl chloride. When this alkyl chloride reacting with sodium cyanide by loss of sodium chloride, they convert into cyano compound. When the cyano compound is under hydrolysis, they give carboxylic acid. So the molecule here, this is the target molecule. The molecule which is chosen in the laboratory for synthesis are called target molecule. The molecule which is chosen in disconnection retrosynthetic analysis is also called target molecule. This is a retrosynthetic analysis process. This is a synthetic process. And next one is retrosynthesis. Next terminology is retrosynthesis. Retrosynthesis. According to E.J. Corey, it is a problem-solving technique for the transformation of target molecule into readily available cheaper starting material is called retrosynthesis. Okay. Now that is a retrosynthesis. Definition here. It according to E.J. Corey, it is a problem-solving technique, and it is a transformation of target molecule into a simple, readily available, cheaper starting material is called retrosynthetic analysis. Okay, when we have taken this is simply carboxylic acid. Simply it is carboxylic acid. When this benzoic acid, it is undergo, it is a target molecule. We are choosing this molecule in the disconnect retrosynthetic analysis, but disconnection is called target molecule. Now with this target molecule undergo retrosynthetic analysis, first it is converted into benzoic acid is converted into toluene. When this toluene is again converted into benzene. Okay, so compared to benzoic acid, toluene is cheaper and readily available starting material. So therefore, the target molecule is converted into readily available cheaper starting material is called retrosynthesis. Okay, this is a retrosynthesis, and synthesis of this benzoic acid from benzene is when this benzene reacting with methyl iodide or methyl chloride in presence of AlCl3 undergo Friedel-Crafts alkylation, they give toluene. When this toluene reacting with KMnO4 oxidation, now it is converted to benzoic acid. Okay, so this is a retrosynthesis. What is the definition is? It is a transformation of target molecule, into a cheaper, readily available starting material is called retrosynthesis. Compared to benzoic acid, toluene is readily available. Compared to benzoic acid, benzene is readily available, cheaper starting material. Therefore, the toluene is chosen as a target molecule in retrosynthesis. In this retrosynthesis, molecules are undergo cleavage, bonds cleavage takes place. This is called disconnection. Next time explain disconnection. Next one is disconnection. Next definition is terminology disconnection. So disconnection means it is an imaginary or hypothetical breakage of covalent bonds in target molecule or in a retrosynthetic analysis is called disconnection. Okay, so when you have taken, when simply here we have taken toluene. In this toluene, we are break this bond that we are break the benzene carbon and methyl carbon. Now it is called disconnection. It is called disconnection. Disconnection means imaginary and hypothetically breakage of covalent bonds in target molecule or reverse of real reaction, or that is a retrosynthetic analysis called disconnection. Okay, so this is a disconnection. Here bond will be broken, then they give benzene and methyl chloride. Simple synthesis is when this benzene reacting with methyl chloride undergo AlCl3, they give toluene. That is a disconnection. Here, another example I am taken here. This for disconnection. Paramethoxybenzaldehyde is I am taken is the target molecule. Paramethoxybenzaldehyde is there taken as a target molecule. Here there is a two bonds are there. Here that there is a two types of disconnections are possible. That is methoxy and benzene carbon bond and carbonyl carbon and benzene carbon bond. So I am assuming this disconnection is the A disconnection, and this disconnection I am assuming as a B disconnection. Okay, if it is undergo, if A bond disconnection takes place, they give methoxybenzene. Anisole is the name. Methoxybenzene is given. Okay, if it is B disconnection, it is B bond disconnection. So here methoxy group eliminated, they give benzaldehyde. Okay, so here in this two disconnections, which is a correct disconnection, which is wrong disconnection means introducing of methoxy group on benzene ring is very difficult. Introducing of methoxy group on benzene ring is very difficult. Therefore, disconnection of B is the correct. Disconnection of B is the correct. Next example. Next terminology. Synthons, very, very important. Synthons. Synthons. Okay. And idealized charger fragments are obtained in disconnection of covalent bonds in target molecule, or retrosynthetic analysis is called synthons. And idealized charger fragments are obtained in disconnection of covalent bonds in target or retrosynthetic analysis is called synthons. Here I am taken simply, before I am taken like this. Here I'm taken nitrobenzene. In this nitrobenzene, this nitrogen and benzene carb bond undergo disconnection. If this bond undergo disconnection, they give minus benzene minus and NO2 plus charge will be given. NO2 plus charge. This is these are called synthons. Okay, what are they? The idealized charger fragments are obtained in disconnection of covalent bonds in target molecule or retrosynthetic analysis are called synthons. So here this is a negative synthon. This is a negative charge containing one species will be formation takes place, and positive charge containing one species will be formation takes place. This negative charge containing species is called negative synthon, and this positive charge containing species is called positive synthon. Okay. Yeah, that means synthons again two types: negative synthons and positive synthons. Okay, so this is a disconnection. And how to prepare this target molecule? How to prepare this target molecule means when we are taken benzene, reacting with HNO3 and H2SO4, HNO3 and H2SO4, nitration takes place. Nitrobenzene is the product. Okay, these are the synthons. Okay, synthons are again two types: so negative synthons and positive synthons. Some examples are there: synthons and synthetic equivalents. Okay, next time explain synthetic equivalents. Synthetic equivalents. Okay, so it is a substance which can generate the synthons and carry out the function of synthons. These are called synthetic equivalents. Okay, simply here, when this target molecule undergo disconnection, they give negative synthon and positive synthon. Okay, for the preparation of this target molecule, I am taken instead of this negative synthon, benzene carbon anion, I am taken as a benzene, and for the positive synthons, nitronium ion, NO2 plus, I am taken this mixture. Okay, these are the called synthetic equivalents for this, and this is called synthetic equivalent for positive synthons. Okay, here as I am given some examples. If it is first synthon, I am given some examples: synthon and synthetic equivalents. Synthons and synthetic equivalents. So for I am given example for synthon. If it is contains R plus, synthetic equivalence is Rx. Okay, if it is undergo disconnection like this, R plus and X minus. Okay, R plus is given like this. Therefore, this is a source of R plus. This is a source of R plus. Okay, these are the synthons. And if I am taken NO2 plus, for this NO2 plus, that synthetic equivalence is HNO3 and H2SO4. The other synthetic equivalents for the NO2. Okay, these two mixture gives NO2 plus. When I am taken acyl carbocation. This acyl carbocation, how to formation of this acyl carbocation means, this is that when acyl chloride reacting with AlCl3, this mixture they gives acyl carbocation. Therefore, this is a synthetic equivalence. What is a synthetic equivalence means? These are the substance which can carry out the synthon and generate the synthons. This is generate the synthon and carry out the synthon. Okay, like this. Therefore, it is called synthetic equivalent for this acyl carbocation. And we take in another. I am taking this alcohol. positive charge. Okay, and synthetic equivalent for this is aldehyde. When aldehyde reacting with acid medium, then gives OH attached carbon positive charge synthetic equivalents. And another example is here. Here, another example is benzene negative charge. For benzene negative charge, synthetic equivalent is phenyl magnesium halide. Phenyl magnesium halide, they gives phenyl carbon anion. Okay, the bond gives a bond undergo disconnected and magnesium plus, and this benzene ring gets negative charge like this. Like this, these are the general examples for synthons and synthetic equivalents. And different examples are there in your book, and go and refer. Next one is strategic bond. Strategic bond. Okay, strategic bond means the bond which are potentially disconnected in the molecule to get a simple starting material is called strategic bond. The bond which are potentially disconnected in the molecule to get a simple starting material is called strategic bond. Okay, that means the bond, for example, I am taken here. I am taken acetophenone is the molecule. In this, there is a two possibilities or disconnections are there, and this is a disconnection, A bond disconnection, and B bond disconnection. If disconnection of A bond, if disconnection of A bond takes place, then gives phenyl carbocation and here methyl negative charge. These are the synthons. And if this B bond undergo disconnection, B bond undergo disconnection, they give phenyl minus charge plus acyl carbocation. Acyl carbocation is given. Okay, these are the synthons, and synthetic equivalents of these molecules are. So I am taking this as synthetic equivalent, and for this I am taking phenyl bromide is the synthetic equivalent. Here for this I am taking phenyl magnesium bromide, and for this I am taking as a acyl chloride. Okay, here two bonds are there in this molecule. They undergo two types of cleavages are there. Here two types of cleavages are there. Which cleavage is correct? Which cleavage is correct means here two cleavages are there. So one is now one is cleavaging disconnection of A bond, disconnection of B bond. So disconnection of B bond is very easy because disconnection of B bond is good disconnection because they give readily available cheaper starting material, and synthesis of this reverse process is very easy compared to here. Okay, very difficult to synthesis of this molecule from this way. Synthesis of this target molecule from this way is very difficult compared to this disconnection. Therefore, disconnection of B bond is good disconnection, and this bond is called strategic bond. This bond is called strategic bond. That means the bond potentially undergo disconnection, they give readily available cheaper starting material, then that bond is called strategic bond. This bond undergo disconnection in this molecule, they give readily available cheaper starting material, and the synthesis of the reverse target molecule is very easy. Therefore, this B bond disconnection is the strategic bond disconnection. Next, transform. Simply we represented TF. Transform. Transform definition. It is an exact reverse of synthetic reaction to target. It is exactly a reverse of synthetic reaction to target. Okay. So simply I am taken here. If here I am taken here, this is that I am taking this is a molecule, target molecule. In this target molecule, they undergo disconnection. They gives double bond O, H, formaldehyde, and ketone. Acetone is the given. Okay, this is the target molecule, and synthesis is aldol synthesis. Influence of base, they give C H2 CH double bond, CH2 double bond, CH3. So this is a transform. Transform means it is exactly reverse of synthetic reaction to the target molecule. Okay, this is a transform. The naming of transform means this is aldol reaction. Therefore, this is called aldol transform. This reaction is aldol transform. Okay, like this. Next one is retron. Next one is retron. Retron means the subunit of molecule which is kept for disconnection in retrosynthetic analysis or disconnection is called retron. Retron is a subunit of molecule which is kept for the disconnection in retrosynthetic analysis or disconnection. I am taken this a molecule. In this molecule, undergo disconnection. This is a target molecule. This target molecule under retrosynthetic analysis undergo disconnection takes place. Disconnection takes place here like this. The disconnection takes place like this, and here in this molecule, in this target molecule, the disconnection takes place at this spot only. In this target molecule, disconnection takes place only at this position, and therefore this position is called retron. The subunit of this mole molecule, in this whole molecule, this subunit, only this subunit undergo disconnection. Therefore, this subunit is called retron. Okay, I'm given some examples here. Here. So now retrosynthetic analysis of phenyl acetic acid. So before that, I'm given some examples, some two definitions are there. Functional group addition. Functional group addition. Group addition. FGA. Functional group addition. Functional group addition, FGA. In this functional group addition means during the reaction, that is during the synthesis reaction, if the functional group is introduced, that is called functional group addition. When we are using taken benzene, this benzene undergo nitration. Benzene undergo nitration. when benzene undergo nitration by using HNO3 and H2SO4. The nitro function group is introducing on benzene. Therefore, this reaction is called function group addition. During the reaction, function group is addition takes place. That is called function group addition. Okay, on benzene, nitration takes place. This function group addition takes place, and I am taken indole. Second example is indole. When this indole converted to indole 3 carbaldehyde, indole is converted to indole 3 carbaldehyde in presence of Wills-Meyer-Hack reaction. Therefore, the addition of indole function aldehyde function group introducing a third position of indole. Therefore, this step is called function group addition. Next example is function group interconversion. FGI, functional group interconversional. Functional group interconversion. So, conversion of function group in one form to another form is called function group interconversion. Simply, I am taken when benzene on acylation, on benzene alkylation, they give toluene. This is a function group addition. Addition of one function group on benzene. So therefore, this is a function group addition. Methyl function group is introducing on benzene. Therefore, it is a function group addition. When this function methyl group undergo converted into carboxylic acid, methyl is converted to carboxylic acid. Methyl function group is converted into carboxylic acid function group. Therefore, this step is called function group interconversion. Conversion of one function groups in one form to another form. Here, their methyl function group is converted into carboxylic acid function group. Therefore, this step is called function group interconversion. Next one. One example I am given here. Retrosynthetic analysis of phenyl acetic acid. Retrosynthetic analysis of phenyl acetic acid. This is a phenyl acetic acid. When this phenyl acetic acid undergo disconnection at alpha bond, then gives benzyl carbocation and carboxylic acid. Carboxylic acid. This carboxylic acid is converted into cyano group. Okay. This benzyl carbocation is a synthon. It is synthetic equivalent of benzyl carbocation is benzyl bromide is the synthetic equivalence. Okay. When synthesis of this target molecule, that is a phenyl acetic acid, is from benzyl bromide. Then this benzyl bromide reacting with sodium cyanide, they convert into cyanide, benzyl cyanide. This benzyl nitrile undergo hydrolysis. They give benzyl acetic acid. The synthetic synthesis of retrosynthetic analysis of phenyl acetic acid. Next one is criteria for selection of target molecule. Next one is criteria for selection of target molecule. For selection of target molecule. So here 5 criteria are there. One, structural verification, biological. Second one is biological activity. Third one is analog studies. Fourth one is topological studies. Fifth one is development of new reagent and reactions. First one is structural verification. Structural verification. Some of the molecules are proposed the structure incomplete. Such type of compounds can be selected as a target molecule for the synthesis in laboratories. Best example for structural incompleting target molecules are periplanon B. Periplanon B. This is a periplanon B. Periplanon. This is a periplanon B. So, structural verification. Some of the molecules are proposed their incomplete structure. That type of structure molecules are taken as a target molecule to develop complete structure and synthesis in laboratories. Best example is periplanon B. This periplanon B is a hormone secreted by American female virgin cockroaches that is called Periplaneta americana. The cockroach Periplaneta americana cockroach is secreted release this periplanon B hormone. So in these 16 stereoisomeric isomers are possible. Therefore, to develop this complete 16 stereoisomer structures, they want a large quantity of the compound we need. But this Periplaneta americana cockroaches releases very less amount of hormones. Therefore, we are synthesize this molecule in laboratory and develop the complete structure of the molecule. Therefore, this molecule is taken as a target molecule in synthesis of laboratory. Next one is biological activity. Next one is biological activity. Here, there are several natural products are good biological activity, but their yield is very poor. To produce in large amount of such biological activity compounds, one has to be taken up the synthesis of the compound in laboratory. Such type of compounds are chosen as a target molecule. Here, that example is prostaglandins. Prostaglandin is the hormone that these prostaglandin hormones secreted in our body, human body, in 24 hours. Within 24 hours, this prostaglandin hormone is released 1 to 2 milligrams. 1 to 2 milligrams are released, takes place. But these are very good biological activity. These are very good biological activity. So therefore, we have to produce a large amount in laboratory. Therefore, we taken this molecule is a target molecule. Okay, these are the biological activity. Next one is analog studies. Analog studies. Same analogs means same structure but small changes is called analogs. In order to reduce the side effects and improve the medicinal activity, structural modification is required so that compounds which are generated for good activity molecules, we are taken analog structures. Best example is penicillins. Penicillin analog or amoxicillin ampicillin. Okay, compared to penicillin, the analog penicillin analogs, amoxicillin ampicillins shows more good, more and better antibiotic activity. Therefore, compared to pencil, we are taken their analogs and amoxicillin and ampicillin are chosen as a antibiotic drugs. Next, topological studies. Here, topological studies. Topological studies means, topology means study of the shape of the structures of the molecules is called topology. The study of structures of molecule is called topological studies. Some molecules are proposed a bulk structures. Example I am taken here. This is a molecule. This is a very crucial structure. So this is the name of this compound is dodecahedron. So this type of complicated structure molecules are taken as a target molecule to give a simple structure, convert into simple structure. Therefore, this molecule is taken as a target molecules. So these are the criteria for selection of target molecule. One is structural verification. Second one is biological activity. Third one is analog studies. Fourth one is topological studies. Next topic is yes. And next one is development of new reagent and new reactions. Development of new reagents and new reactions. New reagents and new reactions. Development of new reactions and new reagents and new reactions. In the synthesis of vitamin B12, which are Woodward and Emil Fischer in introducing a new reagent that is called vinyl nitron. Introducing a new reagent that is vinyl nitron. This vinyl nitron is the specific reagent to reduce vinyl nitron. This is a vinyl nitron. This vinyl nitron is used for the specific reduction of amide groups in presence of esters. Means if there is a molecule, assuming this is a molecule, in this molecule, if there is a amide and ester group is there, amide and ester group is there. In presence of ester group, amide only reduced. Amide only reduced. For the reduction of amides in presence of esters, we are using vinyl nitron is the reagent. This reagent is developed by Woodward and Emil Fischer. These are the criteria for selection of target molecules. One is structural verification and biological activity, analog studies, and topological studies, and new reagents and new reactions. And next one is different strategies and strategies for retrosynthetic analysis. Different strategies for retrosynthetic analysis. One is different strategies for retrosynthetic analysis. One is transform based strategies. Transform based strategies. First one is transform based strategy. These strategies are based on identifying powerful transform for a specific target, which gives a maximum specific simplifications. Different transforms can be repeatedly applied to result a minimum specifications in the retrosynthetic analysis. In here, I am taking 1,5 dicarbonyl compounds, 1,5 diketo compound. This is a 1,5 diketo compound undergo Michael transform. Michael transform. They gives here bond cleavage like this. They gives acetophenone and alpha beta unsaturated carbonyl compounds. Okay, these are transform based strategies. Second one is structural goal strategies. Structural goal strategies. These strategies depends on the identification of a potential strategic materials, building blockers, retrosynthetic subunits. Best example for this structural goal strategies. I'm taking a bulky, complicated structure. So when it is target molecule undergo disconnection, plus ammonia and chlorobromoalkene, pipergine and pyrimidine, 2-halopyrimidine. These are starting materials and topological strategies. So we know already the topologically is complicatedly is depends upon the degree of connectivities. That means a complicated structure is a large structure is converted into simply readily cheaper molecule structure is called topological strategies. Topological strategies. Topological strategies means a complicated structure in undergo disconnection to give a simple and easy molecule. Is a complicated structure. They undergo disconnection. They give a simple molecules. Easy molecules is called topological strategies and stereochemical strategies. Remove of stereochemical strategies. So stereochemical strategies means remove of function groups and chirality is stereochemical strategies. Transdecane in this molecule undergo removal of function groups and chirality is the stereochemical strategies. Through disconnection, they use cis compound. This is the stereochemical strategy and functional group oriented strategy. Last one is functional group oriented strategy. This strategy utilizes the role of various functional groups, interconversion, addition, and removal methods for the retrosynthetic simplification of target molecules. Functional group oriented strategy. Functional group oriented strategies. In this method is utilize the role of various functional group, interconversion, addition, and removal methods for the retrosynthetic simplification of the target molecules. Here, ester and amine, and it is undergo functional group interconversion. Ester is converted to carboxylic acid. Now it is an amine converted to nitro, and carboxylic acid converted to methyl and toluene. So this is the function group orientation strategies. So this is a today topic. That is introduction and target molecule selection and terminology in synthetic strategies. Next class I will continue the unit 12. Thank you.
సార్ నోట్స్ షేర్ చేస్తారు సార్
యూనిట్ అయిపోయాక షేర్ చేస్తాను.
ఓకే థ్యాంక్ యూ సార్.